This is a typical lathe, and as you see, it's highly primitive. One of the oldest type of lathes we use in around probably 1960s, 70s. We now have much the computerized versions, CNC type of lathes, but this is a nice image showing actually all the components on the lathe. What type of parts do we have? Now I will discuss all these sections. Now I can now briefly start with bed. I will mark the things actually I'm discussing. This whole part, actually large part, is called as bed, and it should be manufactured from probably cast iron. It should be as huge as possible. It should be stable. It should withstand to some vibrations, high forces. It shouldn't be bended. So the manufacturing of bed is quite important, and it should be stable since all other components on the lathe are mounted on the bed. And then what do we have here? Let me focus on this side. We have headstock assembly. This is actually all the wheels, all the things are here in this headstock. We have some electric motors. We have some pulleys, sometimes gearboxes. What we are doing with the help of these mechanical equipment, we are trying to actually set the speed of this spindle. The spindle is here. This is a spindle. It's rotating at very high speeds, 10,000 RPM, 2,000 RPM, depends on the capabilities of the machine. And what we do simply, we mount our workpiece into this spindle. Assume that we have a circular shape, like this one, cylindrical shape. It is mounted into this spindle with the help of some special chuck. As you see, this is a spindle with a chuck. We'll discuss what a chuck is. It's actually a kind of a work holding device. This is work, by the way. It's called as work instead of workpiece. We mount it into the spindle and then hold it, clamp it with the help of these chucks. It's one of the most popular work holding devices. We will see that there are different types of work holding devices, but right now we have chuck on this image. And then on this headstock assembly, we have some kind of selectors. These are kind of wheels or some arms. You see such kind of arms. With the help of them, you can set the speed in the earlier days, but in the CNC versions, you only write a simple instruction and then it sets the speed in an automated manner. And then, as you see, we have another arm for feed selector. The feed of our actually cutting tool into the workpiece, but the upper portion is responsible for setting the speed of this spindle. Or we can say that since workpiece is mounted into the spindle, we are setting the rotational speed of our workpiece. And then we have another important component as carriage. This is actually the carriage, this whole part. This part whole is actually named as carriage, and it can move along this actually axis in x-axis, and with the help of actually over the feed rod. We have such kind of rods as you see here to make it actually stable and move along the x-axis easily. And then we have additional lead screw. So in the lead screw, we obviously have such leads. With the help of it, actually, we can have a relative motion between the spindle and the carriage. So this is highly important. With the help of this lead screw, we try to provide a motion, an automated motion to our carriage so that we can open some special profiles, or we can even open some threads, outer threads, external threads, or internal threads. Without them, it's not possible to have a controlled motion between the spindles and the carriage. And if you look at this carriage, let's focus on carriage a little bit. We have apron. So there are some, again, wheels, some arms. You can do some settings. You can move some items on the carriage with the help of this wheels and arms. They are all called as apron. And then on top of this carriage, we have a cross slide. It's a mechanical thing, and it's moving in z-axis. This is, by the way, z, and this is x. This cross slide is moving in z so that we can move our tool with the help of it, and then On top of this cross slide, we have compound rest. And this compound rest is actually rotating. So it gives us more freedom. With the help of it, we can position our cutting tool properly. And on top of the compound rest, actually, we have tool post. This is tool post. And at the tip of this tool post, we have our cutting tool. And these, again, arms are for clamping or for other functions. And sometimes we will discuss that there might be 4 tools or 6 tools on the tool post, depending on the capability of your machine. But I can say that carriage is moving on the feed truss and lead screw with the help of manual motion or with an automated motion. And this carriage actually have a cross slide which moves in Z direction. And on the cross slide, we have compound rest for rotating this part. This is, by the way, compound rest. And at the top of compound rest, we have a tool post. This is tool post. And at the tip of tool post, we have the cutting tool. So these are all I can say. This was already discussed. And at the, let's say, kind of an underneath of these parts, we have a chip pen. Since we are doing machining, we are generating chips from the workpiece, and they are all down here. They are collected here and then maybe recycled depending on the rules of the company. And this is a clutch just for braking, not that important right now. And as you see, we have other controls on the carriage. You can set longitudinal transfer feed control. And let me now focus on this right-hand side. This is actually called as tailstock assembly. This part is tailstock assembly, and it's moving in, again, X direction on the actually ways. So we have kind of ways here similar to railways, and with the help of it, we can move this tailstock to right or left. And what is the function of tailstock is that we will see if your workpiece is high or long, assume that your cylindrical shape is this long. Okay, assume that this is your workpiece. If it's highly long, then you cannot easily do machining if you do not actually properly mount your workpiece. With the help of this center, this is dead center, we have a center here, and this dead center moves actually into the end phase of your workpiece. Assume that this is pen is dead center, and it moves directly into the center of your workpiece, so that we will have a stable workpiece rotating at very high speeds. If you do not actually mount it into your dead center, then what will happen that it will bend over, and this will create lots of problems. It will decrease the quality of machining, decrease the life of your cutting tool, and at the end, you will not be able to obtain the desired part. And this is the tip part of the tailstock is called as tailstock quill. So we have a kind of a quill here, and into that quill, what we insert some type of centers. You'll see that there are dead and live centers. As the name implies, live centers are rotating with the workpiece, but dead centers are not rotating. And again, with the hand wheel, we can fix it or move it. We have other arms here. They are all related with some motions of tailstock assembly. And it's not shown here, but we may further have some rests. That might be a fixed rest or a moving rest. What is the function of rest is that you may, if the part is again longer, you may try to kind of have a support underneath. So if you have a support underneath of your longer workpiece, slender workpiece, then you have less bending, you will have less vibration, and quality of your machining will be improved.